Hi guys, that brings me to the last two questions of this exercise. So let's look at question number 46. Question 46 says on the left hand side, which is obviously the more complicated in this one, has cot, cosec, and on the right hand side I have only sine and cos, which means I should convert cot and cosec in the left hand side to sine and cos. So cot would become cos A upon sine A, plus cosec would become 1 upon sine A minus 1, and the denominator becomes cos A upon sine A minus 1 upon sine A plus 1. Let's take the LCM and add these three elements in the numerator. Similarly, add them in the denominator. So my numerator becomes cos A plus 1 minus sine A upon sine A, and the denominator becomes cos A minus 1 plus sine A upon sine A. So this now is division of fractions. So let's just convert the division sign into multiplication. So what I will have is cos A plus 1 minus sine A divided by cos A minus, I am taking minus common, minus 1 minus sine A. The sine A and sine A will get cancelled. So this is what I am left with. So cos A plus 1 minus sine A and cos A minus 1 minus 1 minus sine A. Now this is the point where I rationalize it. Why do I rationalize it? Because I obviously need square relationship. So how will I rationalize it? I will multiply it with cos A plus 1 minus sine A upon cos A plus 1 minus sine A. Perfect. When I rationalize, what do I get? This is cos A plus 1 minus sine A times cos A plus 1 minus sine A, which means cos A plus 1 minus sine A the whole square. And the denominator is x minus y into x plus y, which would mean x square minus y square. So the denominator would become cos square A minus 1 minus sine A whole square, right? Cos square A minus 1 minus sine A whole square. So let's open the numerator and denominator and see what do we get. This is in the form x plus y whole square. So what I get is x square, which is cos square A plus y square, which is 1 minus sine A whole square, plus 2 times cos A times 1 minus sine A. And the denominator is in the form cos square A minus 1 minus sine square A. Sorry, 1 minus sine A whole square. So now instead of cos square A, I can write 1 minus sine square A. So let me just write this as 1 minus sine square A, and this is 1 minus sine A whole square. A reason for this is since cos square A is equal to 1 minus sine square A. There is no other element that I have used in terms of identity yet. All I have done is been using some arithmetic that we've learned and some algebra. Perfect. So now I have cos square A plus 1 minus sine square A. Let me see if I can open the middle term. So this is 1 minus sine square A. So let me just open this as well. So this would become cos square A plus, this would be 1 plus sine square A minus 2 sine A, and this would be plus 2 cos A times 1 minus sine A. I am not leaving this, I am not opening this bracket because I realize now that I have 1 minus sine A in the denominator and I will get 1 minus sine A here as well. In the denominator, this is in the form A square minus B square, which means I can write this as A plus B multiplied with A minus B. So this is the first term here, and then this term remains 1 minus sine A whole square. Done. So here let's see if I have been able to get something. I have a cos square A, I have a sine square A, add them together, it gives me 1. So this is 1 plus 1, that's 2. So that's 2 minus 2 times sine A plus 2 cos A times 1 minus sine A. And in the numerator, in the denominator, do I have anything common? Yes, I have 1 minus sine A common between the first term and the second term. So let me just take 1 minus sine A common. What remains from the first term is 1 plus sine A, and what remains for the second one is 1 minus sine A. Done. The reason for the first one was since sine square A plus cos square A is equal to 1. This is the only thing that I have done from trigonometry here, where I added cos square A and sine square A, which gave me 1. That's how I got 2 here. Anything common between these two elements? Yes, 2 is common. So let me just take 2 common. So this becomes 2 times 1 minus sine A plus 2 cos A times 1 minus sine A. Done. In the denominator, let's open this bracket. So I have 1 minus sine A, and in this bracket I have 1 plus sine A minus 1 plus sine A. Yes, I open the bracket, so minus 1 and plus 1 gets cancelled. Let's see, in this term and this term, do I have anything common? Yes, I have 2 times 1 minus sine A common between both these terms. So if I take 2 times 1 minus sine A common, in the first term I'm left with 1, plus in the second term I'm left with cos A, not 2 I have already taken out. So 1 plus cos A, and in the denominator I have 1 minus sine A times, in the this term I have sine A plus sine A, that's 2 sine A. Anything gets cancelled? Yes, 2 and 2 get cancelled, 1 minus sine A and 1 minus sine A gets cancelled. So what I have now is 1 plus cos A upon sine A, which, let me just break up into 2 separate terms, will be 1 upon sine A plus cos A upon sine A. 1 upon sine A is equal to cosec A. Oh, I don't need to change this. I already realized we have already reached the answer. I don't need to do this step. My mistake. I got confused doing this long question. This in any case is equal to right hand side. I don't need to go any further. So hence proved. Right? A long question. Let's just revise what we did in this question. The important step was realizing that on the right hand side I have cos and sine. That is why I converted all sec, cosec into cos and sine. After I did this, I applied basic rules of algebra, cancelled this, and the next thing we did was rationalization. So this is a step that we've been using regularly of rationalizing. The logic of rationalizing here has been that all our relationships or all our relations between sine and cos are in the square. So rationalizing helps us get square of terms. Perfect. Let's look at the last question of this exercise, which is question number 47. Question 47 says cos theta dot cot, 1 plus sine A upon cosec A minus cot A minus 1 minus sine A upon cosec A plus cot A. So again, I will start with the left hand side. So let's work with the left hand side. So left hand side is, I will take the LCM. If I take the LCM will be cosec A minus cot A times cosec A plus cot A. That's my LCM of the denominator, which means my numerator will become 1 plus sine A times cosec A plus cot A, and the second term will be minus 1 minus sine A times cosec A minus cot A. Again, a long term. Good. So let's see what we can get. What I will get in the denominator first is easier. This is in the form x minus y into x plus y, which means x square minus y square. So that's cosec square A minus cot square A. From here I realize cosec square minus cot square will give me 1. So my denominator is sorted. Let's just open these brackets. So 1 times cosec A gives me cosec A plus 1 times cot A gives me cot A plus sin A into cosec A, which means sin A times 1 upon sin A, because I realize if I convert cosec into 1 upon sine, it'll get cancelled and my life will become simpler. Good. So the next would be plus sin A times cot A. Cot A is also cos A upon sin A. If I convert it like this, my life will become simpler. All this, I've just finished the first part. Let's start looking at the second part of the question in the numerator. So 1 times cosec A, which means cosec A, 1 times minus cot A, which means minus cot A, and negative sin A times cosec A, which means minus sin A times 1 upon sin A, and minus sin A into minus cot A would be plus sin A times cos A upon sin A. Done. So let's cancel whatever we can. Sin A and sin A gets cancelled. Here it gets cancelled. Similarly, here it gets cancelled, and here it gets cancelled. So let's just first finish off with the denominator. Denominator is 1. The reason being, we'll write the reason later. So I have in the numerator, I have cosec A plus cot A plus, this is 1. This is plus cos A and minus. When I open this, this becomes negative cosec A. Done. This becomes plus cot A. Done. And this is minus 1. When I open the bracket, it becomes plus 1. Done. And this is plus cos A. When I open the bracket, it becomes minus cos A. Anything getting cancelled? Yes, cosec A and minus cosec A get cancelled. Plus cos A and minus cos A gets cancelled. So the reason being, since cosec square A minus cot square A is equal to 1. Done. So let us just move on and let's solve. Let's see what is remaining. So in the numerator, I have 1 cot A and 1 more cot A, which means I have in the numerator 2 cot A. So the numerator is 2 cot A. So this term is gone, this term is gone, and I have plus 1, which means plus 2, and the denominator is 1, which means anything common here? Yes, 2 common, which means 2 times 1 plus cot A. This is exactly what they want. This is my right hand side, so hence proved. Done. A long question. Look at the space that I needed to solve this one. Let's look at the homework question. So homework question for you would be question number 44 and 48. Thank you so much. Take care. Be safe. I'll see you with the next video of the next exercise 21B. Bye bye.